Hello good people, I'm going to continue talking about classification of matter. In particular, I'm going to look at properties of matter. So here are a few substances. On the far left, I have a slab of sodium. Then I have a spoonful of salt, followed by a glass of water, then some brass, and finally I have some chlorine gas. As a bit of revision, recall that sodium and chlorine are elements, salt and water are compounds, and brass is a homogeneous mixture. For sodium, I could say that it is a metal, it is a solid at room temperature, and it is very flammable. For water, I could say that it is odorless, it's clear, and it has a boiling point of 100 degrees Celsius. For chlorine, I could say that at room temperature it is a gas, it is yellow in color, and it is also very toxic. So all of these things and many more represent properties of matter. But in sciences, we like definitions. And it turns out that broadly speaking, we can talk about two types of properties. The first one is physical property. A physical property can be measured and observed without changing the composition or the identity of a substance. For example, mass, volume, density, melting point, boiling point, color, and many others. So what do I mean by this statement that a physical property can be measured or observed without changing the identity of a substance? Well, let's look at salt, for example. I could measure out the mass of one spoonful of sugar, but I could also measure out a mass of 2 spoonfuls of sugar. The measuring will not change the identity of the salt. It is still salt. I could also determine the boiling point of water. It is 100 degrees Celsius. I could heat up this water until it boils and turns into water vapor. But when it does that, it is still water. I have not changed the identity of the compound. In a similar fashion, I could possibly measure out the volume that this chlorine gas occupies. By measuring the volume, I have not changed the nature of chlorine. It is still chlorine. I might also take a lump of brass, place it in my glass of water, and quickly find out that brass is not soluble in water. Conversely, I could take a little bit of salt, place that in my glass of water, and find out that salt is soluble in water. So solubility is also a physical property. Even when I dissolve this salt in my water, I haven't actually lost salt. It is still there, it is just dissolved. So salt, even in water, has not lost its identity. If I was to evaporate the water, I would recover my salt back. All right. The second type of property that we can have is chemical property. So what is a chemical property? A chemical property is a characteristic of a substance that is observed when the substance undergoes a chemical reaction. When observing or measuring a chemical property, the identity of a substance has to change. What do I mean by that? Well, let me scroll down a little bit. So when we talk about chemical properties of substances, we are really talking about how these substances react with other substances. So for example, I might have some sodium and I'm going to combine it with some chlorine gas. These two substances will react with each other to give me salt. So now I could say that a chemical property of sodium is to react with chlorine to give me salt. And I could also say that a chemical property of chlorine is to react with sodium and give me salt. But for me to observe this chemical property, the identities of both sodium and chlorine need to change. In fact, they are completely lost. Once sodium and chlorine react to give me salt, both of them are used up and we end up with salt. Something completely new with its own set of properties. What do I mean by that? Well, sodium is flammable, it is toxic, and it has a melting point of around 98 degrees Celsius. Chlorine is a gas. It too is toxic, and it has a melting point of around minus 102 degrees Celsius. So these are just some of the properties of sodium and chlorine. What about the properties of salt? Well, they are nothing like the properties of the components that made it. It is not flammable, it is also not toxic, and that is a good thing because we consume a fair amount of salt, and it has a melting point of around 800 degrees Celsius. So once again, to observe a chemical property of a substance, we need to change its identity in the process. Finally, I would like to talk about something called an emergent property. What in the name of all that is covered in chocolate is that? Well, let's look at this above example again. So I have sodium and chlorine, and that will give me salt. The properties of sodium and chlorine cannot be used to predict the properties of salt. In terms of properties themselves, there is no logic here. Something flammable and toxic combines with something else that is toxic, and somehow we end up with something that we can eat. Now, this is not magic, it is chemistry, and it leads us to emergent properties. The fact that salt is not flammable, not toxic, and that we can eat it, is an emergent property. The emergent property of a compound does not have to be connected to the properties of the substances that made up the compound in the first place. And because we like definitions, I could say that an emergent property is a characteristic of a substance that the individual components of that same substance do not have. Another way we could express an emergent property is to say that the whole is the greater than the sum of its parts. Emergent properties are very important in the fields of science, especially chemistry and biology. Although a little bit off the topic, we can make the argument that life and consciousness are emergent properties as well. That is all for now, and I will see you on the flip side.